Hey, so today we'll be going over another algorithm code along and solution explanation, etc. We'll try to do it quickly in order to just keep the video length to about 10 minutes, hopefully. We'll see how that goes. So this problem that you probably already see on the screen is called singleNumber, and basically it's fairly easy to explain, but there are multiple ways to solve it, so I'll be going over about 3 of those ways. And each way has a different approach, and one in particular is sort of a you either know it or you don't type of solution, so don't worry if you don't get that one. So let's just go ahead and read the problem. Given a non-empty array of integers, so immediately it's giving us that it's not empty, so we can ignore that potential edge case. Every element appears twice except for one. Find that single one. Now another detail that's important to note here is that every element appears exactly twice, not more than twice. So we can use that to our advantage. So for example, the first way we're going to solve this, but before we go into that explanation, actually, it says your algorithm should have a linear runtime complexity, and we'll see that this is not too difficult, and then ask, could you implement it without using extra memory? So again, you can do that perhaps at the sacrifice of time complexity. So you can say that if you do, a quadratic solution more brute force, then maybe you don't need that extra memory. You just keep checking every single time. And that could be true, but there is actually a method that you can approach this where you can do both linear runtime complexity and without using extra memory, so constant space. And that is one of those you either know it or you don't, as I just mentioned. So don't worry if you don't know that one. We'll go over it, and I don't think anybody would dock you for simply not knowing something, because it's not something that you'll come up with on the spot for most people anyway, unless you're you know that type of solution. So let's jump straight into it. Well, let's go over the examples real quick. So if we have an input of 2, 2, and 1, then we have 2 2s, but only a single one, so the unique number is 1. Example 2, if we have 4, 1 2 1 2, so we have 1 4, we have a 1, then we have a 2, then we have a second 1 and a second 2. So the 1 and the 2 appear twice each per the input constraints, but the 4 appears only once. So how could we approach this? One way we can do it is to basically go through, and since everything is guaranteed to appear twice except for one element, what we can do is store this in, for example, an object, or I'll be using a set. And if we already see it, then we can delete it. If we don't see it, we can add it. So in that sense, if we use the example line 13, once we get a 4, we put it into the set or object as a key. We see a 1, there's no 1, we put it in. We have a 2, we don't have any 2s, we put it in. Then we see a 1, so we delete the 1 that's already there. Then we see a 2, so we delete the 2 that's already there. And since everything occurs exactly twice except for 1, that'll leave the object or array you have with just one element, and that will be the unique element. So that's going to be the approach here. So I'm only using a set because I don't need a value. I only need access to a key, and because I don't need to store anything more than once. In other words, I don't need to store the number of occurrences, because we know it's not going to exceed twice at the most. So that's why I'm using a set. You don't have to use a set, but I'll call it numSet, and we'll just create one using the built-in set constructor. All right, and so now we'll iterate through nums. Now we do have to iterate through the entire nums every single time, so we'll just use for each, since it's a nums.forEach. And let me just scroll down a little bit, and we'll call the individual element num. Now I know that you can, in the case there's a single value passed in for each, you can just not have the parens, but it's good practice to use them anyway. So that's why I have them. I'm sure the linter is complaining because I never use it. Yep. So what we're going to do is if, so we're going to go into the num set. We're checking for the num set. If it has, I'm pretty sure has is the correct method to check if, like it contains or includes. But for sets, I believe it has. So, and we're looking for num. And if it does, then we do numSet.delete num. So we find that key and we delete it. Else, so if it's not already there, then we numSet.add num. And finally, how do we get that last value out of a set? So one approach to doing that, and it's the way I'm going to do it, is to, well, first of all, we'll do the return. The one thing you have to remember is, at least in an object or a set, when you have a number as a key or anything as a key, all keys are strings. So we're going to have to convert it to a number. So for that, we're going to pass the result into a parseInt, and we'll pass in the spread value of numSet. So by spreading the contents of an object or a numSet or an array, you would basically get their values. Actually, I'm not sure about objects, so hold off on that. But in a set, this works. So we'll spread it, and that should be only one value there. And we'll just pass in the radix parameter as well, because it's good practice. So parseInt, by putting in that second parameter, it's saying that this should be parsed into a base 10 decimal. And if you don't do that, then how parseInt might work, it'll default to 10. But how it might work is, if you, for example, have like a hex looking like number, then it will automatically assume hex and it'll go into a base 16, or it might go into a base 8 by accident. So it's just good practice to use base 10 to really specify it, because then it can't be anything else. So yeah, let's just test this using the given example. I'll just use this one. 221 is kind of a short one. All right, so we'll do const test r equals this guy, and let's get rid of those. So I'm just going to do a quick way to fix that formatting, but you should be in the habit of formatting your code well, so that it's readable, it's well spaced out, it's pretty, basically. All right, so singleNumber, and we'll pass in test r. So this should return the unique number, which is 4, which it does. So this works. There it goes. All right, so what's another way we can do this? So there is an approach you can do where you would, if you need to, then pause the screen, copy this down, what have you. I'm going to keep the test because the tests are going to be valid. But now we're going to do an approach where we use math. So again, we know that every number appears exactly twice except for 1. So what we can do is just take every number in nums, every unique number in nums, and sum it up and multiply by 2. And then take that number and subtract what the actual sum is of the nums array, and we'll see that we're short of the doubled nums by a certain number, and that number is going to be the unique number. So hopefully that made sense. I'm just going to go ahead and code it up, and it might be easier to see as I code it. So numSet, again, we're going to use the set. This time set is even more convenient because we're going to pass in nums. And what this does is it'll take the array and it'll create a set where every number is represented just one time. So what we do now is we'll do a, yes, we need a sum. Let sum equals, or let's say total, because we're going to be calculating 2 sums. So this one's going to be total equals, we'll start at 0. It's just to calculate. So now we're going to do numSet dot for each. Yes. So sets also have access to for each, and each one is going to be a num. And here we're just going to calculate the total. So total plus equals num. And let's make sure that's a semicolon as well. So now we have that total, and now what we're going to do, as I explained earlier, is we're going to take total and we're going to times equal to. So we're just going to double the sum of adding together every unique value in the set, and everything is going to be doubled. As we said, you know, for example, 4, 1, 2, 1, 2, it's just going to take 4, 1, and 2, double that sum, so it's going to get, in this case, 14, because that would be 7 times 2. And the idea is that now we actually take the original array and sum that, and we should get what? 7 plus 3, 10. So we have a 14 and a 10. 14 minus 10, that's 4, because that makes sense, right? Only one of them is only going to occur once, so it's going to be that number less than the total that we calculated on 23 when we multiply every number by 2, assuming that every number had a second instance. So yeah, we have the total, and now we're going to just we'll say sum. So equals, and we're just going to do a one-liner, nums.reduce, because reduce is a good way to sort of get a sum, right, of an array. It's pretty simple. It's basically ACC plus num at each instance, and that should total sum. So now what we do is we will return total, which is the higher number. That's where everything was multiplied by 2. And subtract the actual sum of the array. So maybe not the best two choices of variables. This would be like a doubled total, so you can call it that if you like. So Control D to do this. Double total, for example. That might be more descriptive. So yeah, hopefully that made sense, and that should also work. Let's just test it real quick. Again, we should be getting, oh, so which line is this? Not sure why this didn't work. Doubled total is not defined. Did I have something highlighted maybe? Let's see. I did, yeah, so I must have had something highlighted. So what happens in this particular code runner, which happens to be called code runner, is that if anything is highlighted, it'll treat that as the only code I want to run. And accidents happen quite often. I'm sure you can go back in this video and see exactly why that happened. Probably I had, you know, for example, this highlighted, and so it'd run only that, try to reference double total, and since it's declared outside of the highlighted region, it wouldn't work. So yeah, that's another way that it works, and as you can see it does, because the result is 4. So this final method is sort of a you either know it or you don't. So don't worry if you don't know this one, but this would be the way to do O of n time without using any additional space, and it's actually a one-liner. So it happens to work for this exact situation. So how it works is you just will start with the return value, because I told you it's a one-liner, and we do nums.reduce, and basically all you have to do is, yeah, we'll set up the same thing, is just so what's going on here and why does it work? Except it's complaining, actually. That should be okay. Yeah, it says no bitwise, right? So the linter is complaining that I shouldn't be using a bitwise operator. But yeah, basically this I believe is XOR, and anyone that's watching this and knows I'm saying something wrong, please leave it in the comments. I could also update the description if that turns out to be true. But basically this should be a bitwise XOR operator. So what you're doing is, for every how XOR works, or one of the properties of XOR, is that if you have a number and you XOR it by itself, it totals 0. So basically what's happening is we got the 4, okay, so the 4 is there, and then we have a 1 and another 1, so they cancel each other out, and then we have a 2 and another 2, so they cancel each other out as well. And we're left with just the unique number. And since everything is doubled, XOR will cancel out everything there's 2 instances of and leave only the unique value. So this is a very specific solution that happens to work really perfectly for this given situation. But again, it's a good to know. I don't know the specifics of exactly how Zora works, so you can look up other videos for that, and not on my channel yet, but I'm sure other people will explain to you exactly how Zora works and how bitwise operators works. So I'm not going to pretend like I know how that works, but that is the sort of overview description of why this one works. And it's one of those you have to know it kind of things. I've seen a student that was I believe, computer engineer, if I'm not mistaken, that happened to already know how bitwise works, even though they were not a programmer. So again, you can know it, but most people, it's something that they don't know, and just learn is a possible way to solve this particular problem. So hopefully you enjoyed those 3 solutions. If you have any questions or comments, please let me know how I can improve these videos for you. If I should, talk more clearly, make these shorter, make these longer, add background music, whatever you think would help, then let me know. And otherwise, see you next time.